Hi, this is Alex from devstories.eu. GeoPandas, Episode 3 of 11. You calculate the distance between two cities and your result is 2.4 instead of 200 miles. Your code ran perfectly, but your answer is completely useless. The culprit is how your spatial data maps to the physical world, which brings us to the shape of the Earth, projections, and CRS. Every geoseries and geodata frame has an attribute called .CRS. This stores a PyProj CRS object. It is the metadata that tells GeoPandas exactly what the numbers in your geometry column actually represent. Without a coordinate reference system, a point like -73, 40 is just a point on an infinite abstract grid. With a CRS, it becomes a specific known location on Earth. There are two main categories of coordinate systems you need to understand. Geographic coordinate systems represent the Earth as a three-dimensional globe. Their coordinates are angles measured from the center of the Earth, expressed in degrees of longitude and latitude. A very common example is EPSG 4326, which is the system used by global GPS. Projected coordinate systems, on the other hand, represent the Earth flattened out onto a two-dimensional surface. Their coordinates use linear measurements like meters or US survey feet. Here is the key insight. The spatial operations under the hood of GeoPandas assume your data exists on a flat Cartesian plane. If your data is in a geographic coordinate system like EPSG 4326 and you ask GeoPandas to calculate the area of the New York boroughs, it will run the math treating degrees as if they were simple grid squares. You will get a result like 0.083. That means 0.083 square degrees, which is a meaningless metric. Degrees change their physical width depending on how far you are from the equator, so you cannot use them to measure absolute distance or area. To do real-world math, you must project your geographic data into a projected coordinate system. You do this using a method called 2CRS. If you take that New York data and pass EPSG 2263 into the 2CRS method, GeoPandas will mathematically transform every single coordinate in your geometry column. EPSG 2263 is a projected system specific to New York that measures distances in feet. Now, when you run that exact same area calculation, you get a result in millions of square feet, which is an actual usable measurement. There is a common trap here. Developers often try to fix missing projections using the setCRS method instead of the 2CRS method. setCRS is not a conversion tool. It is only used when your spatial data was loaded missing a coordinate reference system entirely. It simply assigns the metadata, telling GeoPandas what the numbers in your geometry column already are without altering the numbers themselves. You use 2CRS when the data already has a valid CRS and you want to mathematically convert those coordinates into a completely new system. If your area or distance calculations ever look absurdly small, it almost always means you are asking GeoPandas to do flat math on spherical degrees and you need to project your data. That's it for today. Thanks for listening. Go build something cool.